Day 10 of Advent of Code 2025. I think this was the hardest day of the 12 days for me anyway. So, yeah, it was challenging, especially part two. But I'll go over the solution that I eventually came up with and explain it to you to the best of my ability. So let's first of all go over what the problem is and what the input looks like. So the input file is here on the right. We've got these lines of data, and each line is called a machine in the problem description. So there are lights and buttons and something called a joltage. So there are basically three parts to each line. So there's the stuff in the square brackets, and then these tuple values, these integers, and then at the end of the line, at the end of each line, there's a set of integers in curly braces, right? So yeah, and again, this is called a machine in the problem description. If you want to read it, you can go to the website for Advent of Code, right? Let me show you how I parse the input data here. So I just read the file, and then I've got a machine class that I created to just make things a bit easier here. So there are lights and buttons and joltages. So the lights are what's in square brackets. The buttons are the tuples, and then the joltages, as I said, is the stuff in the curly braces at the end. So I've just printed out the first machine here, which is the data in the first line of the file, basically. So the lights are true or false values, basically. So a light can be on or off. In the raw input file here, a light is on if there's a hash symbol, and it's off if there's a period. But I just replaced that with true or false in the list here. And then we have these buttons, which are these integers, right? And so the way it works is that a button toggles a set of lights, right? So the first button toggles the 0th, 1st, 5th, and 8th light. So if you push this button, then that toggles the true or false value here in the set of lights, right? So we've got a number of buttons here, and the problem is to get this configuration of lights from a starting configuration of all false, right? So the lights are all initially off, and then we want to get to this set of true false values by pushing the buttons, right? Or some set of buttons, some subset of buttons, right? And so the problem in particular is to minimize the number of button pushes to get the given light configuration. So the joltages are not used in part one at all, so we can ignore that for now. In terms of coding up a solution, it's helpful to note that pushing a button twice has no effect, right? Because you're just toggling the same values twice, which doesn't change the value, right? So we're going to push each button at most once. So that's equivalent to just picking a subset of the buttons to push to get the desired light configuration. So one way to solve this is to just look at all the subsets of buttons and see if they give the desired light configuration. So let's code up a solution for that. So we're going to look at all the combinations of buttons. We can do that with itertools. Let's import that. And then we're going to do for subset size in range 1. Well, let's put this in a function here. So let's do solve subsets, and then we're given the lights that we want. So lights target, which is a list, right? And buttons, and then we're going to output the number of button pushes, the minimum number, right, to get the lights target, right? So for subset size in range 1, length of buttons plus 1, right, because we may need to push them all. And then we can look at all the combinations. So for buttons to push in itertools dot combinations buttons subset size, right? Now, for each button to push, we're going to well, first of all, I guess we start with the lights all being off. So let's create a list here of false values. Lights target, right? So they're all false initially, and then for each button, button in buttons to push, for B in button, this affects one of the lights, right? So we're going to toggle the light. So lights B equals not lights B. And then we're going to check if let's see. We're going to check if the lights are in the right configuration, right? So if lights is our target, then we're done. We can return subset size. And so something should return at some point here, but if not, we can return 0 here. So that should give the right value for a given machine, and we want to do this for all machines and then add up all the values. So we can do sum of solve subsets and dot lights and dot buttons for M in machines. And that's the answer for part 1. Now for part 2, we basically replace the lights with the joltages. And for each button, each button, instead of toggling the value from true to false or false to true, it increments the joltage, right? So joltages, start at 0, and then we push buttons until we get to the given joltages, right? And again, we want to minimize the number of button pushes to get to the desired joltages. So, for example, these would all start out at 0, but we want to get to 53 here, 78 here, and so on. And this button would increment the 0th, 1st, 5th, and 8th positions, right? So this would be incremented to 1 if it starts at 0, and this would be also 1, and then 2, 3, 4, 5. This would be 1, 6, 7, 8. This would also then be 1, right? And then if we push it again, this would be 2, 2, 2, 2, and so on. And we want to get here by pushing buttons. So this is kind of tricky to think about. We can't just brute force it the way we did it for part 1 because there are just too many possibilities. So I thought about it for a long time and tried different things, but eventually what helped me figure out a solution is to think of this in terms of an optimization problem in linear algebra. So let me scroll down. I've written down some equations here. So basically the problem boils down to this: minimizing this value. X is a vector here, representing the button presses, right? So the first entry in the vector is how many times you push the first button. The second entry is how many times you push the second button, and so on. And so you want to minimize those button presses, the sum of the button presses, right? Subject to this constraint, right? So mx equals j encodes the joltages that we want to get in the end. So we can't just not push any buttons, because then we wouldn't get to the right joltage, right? So that's why there's this constraint here. So M is a matrix of zeros and ones, right? And J is the joltages for the given machine, right? So if you can write your problem in this form, then you can use an optimization solver, right? So I used something called CVXPy. I knew about this because I learned about this in a class in grad school. Otherwise, I would not have known about it, and I would not know how to solve such a problem. But there are software packages that solve this type of problem, right? So if you can just get it in this form, then you just need to call a solver to solve the problem, and that's what I did here. So basically, so J is the joltages, and then M is the matrix of zeros and ones, and then you can look up the documentation for CVXPy to figure out the syntax and how to create these optimization problems. But basically, you have to create a variable, and here you got to set integer equals true, right? Because a button, the number of button presses is a non-negative integer, right? So 0, 1, 2, or 3, or 4, or some number, right? But it can't be 3.2 or something like that, right? So it's got to be an integer. And then we add the constraints here in this way, and then we just create a problem and call the solve method, right? And then we can do we can solve all those problems in about 0.7 seconds, and this is the answer for my input. So it was definitely a tricky problem. It took me a while to figure out how to approach it. I did then look online to see how others solved it. So some people used Z3, which is a different package similar to CVX. You can also use SciPy, or there's a different approach that someone described on Reddit. So you can read up on that. I didn't fully understand it, but it seems to be a clever solution. So I'll post this notebook in my GitHub repo, so you can see the link to the Reddit post there if you're interested. So I hope that was somewhat clear and gave you some insight into the problem and my solution. Thanks for watching, and see you in the next video.